Hello all, good morning. This is Dr. S. Subbalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Matrices and Calculus, and we are on to the topic Eigenvalues and Eigenvectors. In the previous video, we have seen the definition for eigenvalues. The eigenvalues are the roots corresponding to the characteristic equation determinant of A minus lambda I is equal to 0, which is called as the eigenvalues of the matrix. We will be just solving this particular equation and find the values of lambda. Those are called as the eigenvalues of the matrix. Now we will have the properties of the eigenvalues. Properties of eigenvalues. The first property is the main property here. The sum of the eigenvalues of a square matrix A is the sum of the principal diagonal elements, which is called as the trace of A. So if we have a matrix like this, the diagonal element sum will be the sum of the eigenvalues also. So if we find the eigenvalues for the given matrix, then their diagonal element sum will be the eigenvalue sum of the given matrix. This is the one of the property for the eigenvalues, which is called as a trace of A if at all it is only the square matrix. The second property, the product of eigenvalues of a square matrix is equal to the determinant value. So if square matrix characteristic equation is found and the eigenvalues are found, then we can note that the product of eigenvalues of a square matrix is equal to the determinant value of the given matrix. So product of eigenvalues alpha, let we say it as alpha and beta. Alpha into beta will be equal to determinant of A. And the third property is the eigenvalues of a square matrix A and its transpose A transpose are the same. If we find the eigenvalues of the matrix A, and the eigenvalues of the matrix A transpose, both are same. Eigenvalues of the matrix A and the eigenvalues of A transpose, both are same. So this is how we find the eigenvalues. Now, the fourth property we have seen. Fourth property is the eigenvalues of real symmetric matrix are real. The real symmetric matrix means the values are all real, and the symmetric means upper triangular matrix will be equal to the lower triangular matrix. The eigenvalues of a real symmetric matrix are all real. In the fifth property, we will have the eigenvalue of an orthogonal matrix have the same absolute value, which means the orthogonal matrix of the given matrix will have the same absolute value, means positive value. Is positive always. Absolute means which is a positive value always. Now we will have a problem regarding the eigenvalues and eigenvectors. Find the sum and product of the eigenvalues of the given matrix A. Find the sum and product of the eigenvalues of the given matrix A. The matrix is A is equal to minus 1, 1, 1, 1, minus 1, 1 and 1, 1 and minus 1. So on looking at this, we have noticed that it is of the square matrix. The given A is a 3 cross 3 square matrix, which means it is of order 3. Now using property 1, how we will know the sum of the, what we will know about the eigenvalues? Since it is a square matrix of order 3, the diagonal elements sum is equal to the sum of the eigenvalues here. So using property 1, the sum of the eigenvalues of a square matrix A is the sum of the principal diagonal elements. We will have the sum of the eigenvalues is equal to sum of the diagonals, which is minus 1 plus minus 1 plus minus 1, which is equal to minus 3. Now using property 2, we can note that the product of the eigenvalues of a square matrix A is equal to the determinant value, which means the product of eigenvalues is equal to determinant of A, which is equal to, on finding the determinant, we will have it as 4. So we are we are going to find the sum and the product alone of for the square matrix A and B. So to find the sum and product of the eigenvalues, it is enough if we use the properties for the eigenvalues here. Properties of eigenvalues here. We have just used the property number 1 and property number 2. What is property number 1? The sum of the eigenvalues of a square matrix A is equal to the sum of the principal diagonal elements. And what is property number 2? The product of the eigenvalues of a square matrix A is equal to the determinant value. Now, the second problem. Two eigenvalues of a matrix A are 3 and 0. We are going to find the third and the final product. Third eigenvalue, and we are going to find the product also. So how we will find? We will use the property. Using property number 1, we will have lambda 1, lambda 2 and lambda 3 to be the eigenvalues. Sum of the eigenvalues is equal to the sum of the diagonal elements. So 3 plus 0 plus lambda 3 is equal to 18. Now lambda 3 is equal to 15. Now lambda 3 is equal to 15 as discussed with the property here. We will have lambda 3 is equal to 15. Now product of lambda 1 into lambda 2 into lambda 3. As we have listened earlier or as we have done earlier, lambda 1 is 3, lambda 2 is 0 is from the given and lambda 3 is equal to 15. We will have the product of the eigenvalues to be 0. So this is how we use a property of eigenvalue to find the given set of questions in the problem. So we will have set of some more lecture video and case study video in the next videos. Thank you.